Okay, guys, so we are still in section 4.2 in the note-taking guide. It is page 78 that we're on right now, and we're just going to finish the notes that we started last class that we didn't quite get to finish. And we left off, we did this example where we were graphing and we were plugging in inputs for X and getting out some outputs for Y, and we've done this before this year, so this wasn't really a new thing for us. We left off where we found these four particular X and Y ordered pairs, and then we graphed them, and I just don't think that we ever connected our line to show that it really represents all of the solutions that are on that line. So before we go on, I just want to start talking about making some observations about this line and see if you guys can start to come to some conclusions about what the different numbers mean in the actual function form for this. So if we're looking at this, which direction does this line go? If you're going from left to right, this line go uphill or downhill? Definitely uphill. So I'm just going to make some little observations down here. Uphill. Okay, where does it hit the y-axis? Here's our y-axis. Where does it hit that? Because that determines kind of how far up or down in the graph it is. So it hits the y-axis. Let's say hits y-axis at -1. All right. Now, if you guys keep paying attention to these trends, you're going to see that these things right here really directly correspond to these numbers right here. This guy, this -1, that's going to be where it hits the y-axis. This guy right here, this 2, controls whether it's going up or down and how steep it is. So we'll keep graphing a few more, and let's keep that in mind when we're looking at it and see if you can see how those numbers control what this graph actually looks like with all these solutions. So let's do number 3 really quickly, and I know you did some of these for homework already, so this is just going to be another warm-up where we're finding 4 solutions. So I'm going to do my work down here, make a little XY table, and I'm going to say, okay, well, let's do our same 4, -1, 0, 1, and 2. And I'm going to make them ordered pairs already, so I don't forget to do that. And then I'm going to look and see, can I go ahead and plug in X? Is this already written in that Y equals format, Y equals MX plus B or something X plus something? And yes, it is. We don't even have to solve for Y. They made it easy for us. So I'm going to start plugging in. Y equals -4 instead of X. -4 times -1 plus 1. So negative times a negative is a +4 plus 1 gives me a 5 for this one. And you guys can keep going ahead and doing this and showing your work. I'm going to do -4 times 0 this time. Love 0. 0 is the easiest because that's just nothing. All you have left is a 1. All right, what if I plug in 1? -4 times 1 plus 1. -4 plus 1 is -3. You guys know if you're listening to this on your own, you can always pause this if I'm going too fast, and you can do it, and you can come check it. I get -3 there. I'll use this space here. Y equals -4 times 2 plus 1. -8 plus 1 plus 1 is going to be a -7. So I've got my answers in there. And guys, do we see a pattern in the Y's? What's happening with those Y's? Every time it's going down by 4. Okay, take a look at this number. That controls it. Going down by 4. Every time the X goes up by 1, the Y is going down by 4. If we graph this now, let's look and see what this graph actually looks like. So -1, 5. Ooh, let's see. This is 2, 3, 4. This is going up by 2's every time. So we've got to be careful with our graph here. And this, it looks like it's only going by 1's on the X-axis. So let's see. 1 this way and up 5 here. That's going to be right there. 0 and up 1 is going to be right here. Side to side, a whole 1 and down to 3. Let's see, -2. So -3 is going to be halfway here. And 2, -7, that's going to be halfway here. Okay, looks like it's going to be a line. So we're going to connect our dots. Put arrows on either end. What can we say, what observations can we make about this particular line? From left to right, is it going uphill or downhill? This one's going downhill. And that's because of this negative. You see up here, this one had a positive number, makes it go uphill. This negative number in front of the X is making it go downhill because it's controlling the pattern of the Y's. They're going down. What about where this hits the Y-axis? Hits the Y-axis at 1, and that's this number right here. And essentially, guys, it's because when you put in 0 for x, when your x is 0, all that's going to be left is this number right here. So 0, that number. That's where it's got to hit the y-axis. All right, so we started looking at some graphs, looking at some trends. We're going to continue to do that. We're just going to look at a couple more problems where they don't have this kind of table that we have to figure out, and that they're not exactly written in this y equals mx plus b form. So let me flip back a page. Can you go back to 77 where we skipped before? Get this under here. I hope you can see my pink coming through the page there. We're going to look at these equations in example 2. So it says we're going to graph y equals -3, and we're also going to graph x equals 2. All right, here's the deal. If you made a table of values, let's use this y equals -3 first. Guys, whatever you plugged in for x, let's say we did -1, is there a place to plug in -1 for x? No, there isn't, because y always equals -3. It doesn't matter what x is, y is -3. If I said my x was 0, does it matter? No, because y equals -3. If I said my x was 1, what's y going to equal? -3. So what's that going to look like on the graph? No matter where you go side to side, you're always going to end up going down to -3. -1, -3, 0, -3, 1, -3. This is going to be our graph for y equals -3. That's not too bad, huh? We didn't even have to plug anything in. All we had to realize was that our y is always going to be a -3. And we looked at these before when we were talking about whether things were functions or not. Is this a function? Does it pass that vertical line test for each input? Is there only one output? Yes. It doesn't matter if the outputs are repeated. For -1, you're only going to get -3. So this is a function. So when we fill this in, regardless of the value of x, the value of y is always -3. So the graph of y equals -3 is, what kind of line is that? What do we call that? It's horizontal. It's a horizontal line 3 units below the x-axis. We could say it's at y equals -3. All right, so let's take a look now for part B. The equation that we're going to graph is this guy, x equals 2. Do that in a different color for us. So x equals 2. I'm going to just move this down, and I'm going to rewrite down here. We're doing x equals 2. So if we were to do a chart, some ordered pairs for this, guys, x always equals 2. 2, 2, 2. We could do another one if we wanted to. It doesn't matter. We can pick any y's we want, and x is always going to equal 2. So what if I picked, -1, 0, 1, 2. It doesn't really matter what I have. I'm always going to go side to side to 2 first. 2, -1, 2, 0, 2, 1, 2, 2. It's going to be a line that goes this way. That is x equals 2. Regardless of the value of y, the value of x is always 2. So what kind of line is this? This is not horizontal. This is vertical. And it's 2 units to the right, where x equals 2. 2 units to the right. Is this guy a function? Would this pass the vertical line test? No, what if we drew a vertical line right here? It's going to hit every single one. Look at this. For every input, there are different outputs. If you put in 2, you're going to get every single thing you could possibly get. This is absolutely not a function. So that's just important for us to kind of keep in the back of our mind. Let's do a couple more practice problems with that. All right, here we go. Can you guys graph on page 20? No, we're on 78. Page 78, can you graph x equals 0.5? No matter what y is, x is always 0.5. X is always a half this way. Half this way. Look like that? Yeah? All right, let's try the number 4 down here with a y. So in this case, y is always -1.5. So we go side to side, whatever, it doesn't matter. We're going to end up going down -1.5, which is right here. Side to side, whatever, down -1.5. It's going to be a horizontal line going this way. All right. So there was our practice with just x's and y's. Could you write these as y equals mx plus b? No, because they only have one variable. So this is going to be our exception to the rule of having the y equals mx plus b for a linear equation. All right, let's look at just the last examples that sometimes we look at when we're graphing linear equations with this table method. Sometimes we are going to look at something like on page 79 here, example 3, where they give us a graph. Here's our linear equation, and we're restricting the domain. We say we only want to look at domains where x is greater than 0, greater than or equal to 0 in this case, and then identify the range. So can we make a table the same way we've been making for this? And let's graph this, and let's take a look. But in this case, would I do x is negative 1? No, in this case, I wouldn't, because I'm only looking at a domain, the x's, where x is greater than or equal to 0. So in this table, and I like doing mine up and down, in this table, there's no point in doing a negative 1 because I'm not looking at that part of the graph. I'm just doing 0, 1, 2. Let's add a 3, just so that we can get 4 ordered pairs on here. All right, so if you want to pause it and do this and catch up and see if you've got it, awesome. Otherwise, I'm just going to go ahead and do it right now off to the side. 2 times 0, that's always a lovely one. It ends up being just 2. And this time I'm plugging in 1. 2 plus 2 is 4. This one I'm going to plug in 2. So 2 times 2 plus 2. 4 plus 2 is 6. I'm seeing a pattern. I'm hoping that this one is going to be 8. 2 times 3 plus 2 is 6 plus 2, which is 8. I went super fast there. If you need to pause and do that on your own, please do. So there's my table. Can I plot the points? Can I plot the ordered pairs? We made a table. We're plotting the ordered pairs, the points. 0, 2 would be here. 1, 4 looks like it would be here. 2, 6, 3, 8. Does it look like it's going to be a straight line? Yep, this time we just have to be careful that when we connect the dots, there's the phone, hang on. Okay, sorry, I'm back. So when we connect the dots here, we cannot connect them the way we have been, where it's a straight line with the arrows going on in both directions, because in this case, we're only looking at points where the x is 0 or more. So in this case, I'm going to connect everything to the right of 0, like this, but I am not going to look at any points that are further down here because we've restricted our domain. So we're going to connect the points. Do you remember what that thing is called? Not a line, but a ray, where there's an arrow on one side, because we say the domain it's restricted. We're only looking at a specific part of the domain. Okay, now in this case, can we identify the range? We've done this before. We've identified domain and range. What does it look like from the graph? In this graph, y can be anything that is 2 or greater. The y is not going to go anywhere below 2. So that we would say the range, I'm going to say it down here, the range is going to be y is greater than or equal to 2. Remember doing that before. All right, so that's how we do something where we're restricting a domain. Let's just do one example of that, and then we'll be done. Okay. Graph this function, y equals negative x plus 4, with a domain of x is greater than or equal to 0. I'm going to go ahead and do a few points here. Let's do 0, 1, 2, 3, 4, this, or 1, 2, 3 this time, because, again, we don't care about any x's that are less than 0 at this point. So if I'm going to graph it, negative 0, well, that's just 0. That just leaves us with 4. Negative 1 plus 4 would be 3. Negative 2 plus 4 would be 2. And negative 3 plus 4 is going to be 1. There are our ordered pairs. And again, 0, 4, 1, 3, 2, 2, 3, 1. Are we going to connect this with arrows on both ends? Nope, because we only care about the domain x is greater than or equal to 0. Only things this way. So what would be the range of this particular function right here, this graph? The range, let's see, the highest that y can be is 4. right? So y is going to be anything now that is 4, or it could be less because it's going to keep going down forever. So the range is going to be y is less than or equal to 4. All right, we might see some more practice problems with that. All right, I'm going to let you guys do the next thing on your practice list.